Okay, so this is the second part of this Chapter 5 review for my Algebra 2 students for their test Tuesday and Wednesday. You should watch both parts before Tuesday, but this part should be watched second. There's a previous video with questions 1 through 4. But here's number 5. We're going to use the quadratic formula. So let's remind ourselves what the quadratic formula is. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And remember, this part in here is called the discriminant. The discriminant. Okay, and we usually always find that first before we do any problems. So let's take a look at this question here. We're going to use the quadratic formula to solve. 3x squared plus 2x equals x squared minus 5x minus 1. Alright. And actually, I'm going to do something real fast. I'm going to change this sign right here to a minus 2x. Okay? Not a big deal. I just want to do something for the problem. Okay. So, and this one to a plus 5x. So make sure you rewrote this problem as 3x squared minus 2x equals x squared plus 5x minus 1. Rewrite that. So we need to get 0 on one side. You cannot use the quadratic formula until this thing equals 0. Now, in order to keep x squared positive, I always suggest moving everything to the left, because that'll keep your x squared positive, and that's what you want to do. So move everything to the left. And when you do that, you're going to get 2x squared minus 7x plus 1 equals, and 0. All this stuff will go away. Now, let's start by using the discriminant. Okay, so the discriminant here is this part inside the square root, b squared. Now, the reason I wanted to change those signs is because I wanted to make b negative, to force you to use parentheses. If you don't, you'll get the wrong answer, and we don't want that to happen. We don't want that to happen, okay? So when you get the discriminant found, it comes out to be 41. Okay. So 41 is greater than 0, which means you're going to have 2 real solutions. Make sure you understand what happens when it's equal to 0 and when it's less than 0. Make sure you know what the discriminant means. Okay? And remember, if I was to graph this, 2 real solutions mean that it has 2 x-intercepts. So remember that. Alright. So nonetheless, we go to the quadratic formula. X equals opposite of b. b is negative 7. Opposite of negative 7 is positive 7. Square root of my discriminant, which is 41, all over 2a. a is 2. 2a is 4. So I want the decimal answers. So I want the 7 plus square root of 41 over 4 and 7 minus square root of 41 over 4. Make sure you use parentheses if you plug it in all at once. Okay? Be very careful. So if I use my calculator here, parentheses 7 plus the square root of 41 divided by 4. I get to 3 decimal places. That's what we'll round to. 3.351. Okay, and if I do the minus part, 0.149. And there's my 2 answers to this problem using the quadratic formula. So this was a question involving the discriminant and the quadratic formula. Okay, so this problem is one of those initial velocity problems. I'm going to give you this formula. This formula says h sub f equals negative 16 t squared plus v sub I t plus h sub I. Okay, so I'll give that to you. You just need to know how to fill it in. So we're going to talk about not 3 objects, just 2. We're going to talk about the 2 objects. We're going to talk about the first and the third. The second object that's dropped, we're not going to talk about. Okay? Because when you drop an object, there is no initial velocity. Alright? So let's go with the first object here. It says the first, so 3 objects are launched from the top of a 100-foot building. So we have a building here. And it's 100 feet. So that's your initial height. Your h sub I is 100. And you have an object that's launched upward at an initial velocity of 10 feet per second. So something's here, and it goes up. Up 10 feet. So the initial velocity is 10 feet per second. And we want to know when it hits the ground. All right. Our third object, we'll come over here. Our third object, same thing. So its initial height is 100. But this guy is, he's thrown downward. Now when you throw an object downward, your initial velocity going down is negative. Okay, and it's still 10 feet per second. And again, we want to know when it hits the ground. So when is your final height? 0. So here's the two setups. So the only thing that's different is the initial velocities. Now you think about which one's going to hit the ground first, right? The third object should hit the ground first because you're throwing it down. But let's see what happens. Okay. So fill in your equations. So h final equals negative 16t squared plus your initial velocity, which is 10t, and then plus your initial height, which is 100. This is equal to 0, so we'll use our discriminant. And the discriminant here would be 10 squared b squared minus 4 times a times c. So we have 100 minus 4 times negative 16 times 100. 6,500 is what I got for this discriminant. So when we fill in our quadratic formula, and notice I use t this time because x is not a variable, it's t. T equals the opposite of b plus or minus the square root of our discriminant all over 2a. And I want to get the plus and the minus answers. So not there, but up here. The plus and the minus answers. Okay, and hopefully we can throw one of them out. We'll see. So when you do the problem, negative 10 plus the square root of 6,500. I got negative 2.2, and we'll go 1 for the plus answer, and 2.83 for the minus answer. So of course we keep the positive one. So this one happened in 2.83 seconds. All right. Now let's take a look at the other problem here. So this time we'll fill in the equation here. We have 0 equals negative 16t squared. Now your velocity is negative minus 10t plus 100. All right. The discriminant, now notice the only thing that changed is the negative 10, so your discriminant should not change. Because when you square that negative 10, it still becomes 100. Right? It still becomes positive, so your discriminant will not change. So when you fill it in, the only thing that changes now is your b. b is now negative, so the opposite of a negative is a positive. So it's opposite of b plus or minus the square root of your discriminant all over 2a. And I want the two answers. I want the plus answer and the minus answer. And again, this is easy too. You just go into your calculator, take away that negative in front of the 10. So my minus answer is 2.21. And my plus answer is negative 2.83. So I take away the minus, and I keep the plus, 2.21. And you see that it gets there a little bit faster than the other object. All right. So that's the initial velocity equation. Draw a picture. Okay, so the last problem we'll do here is an inequality problem, okay? So remember, we treat an inequality problem just like an equation. However, the answer is a little bit different because we're looking for a range of values, right? An interval of values, not just a couple answers. So here's my inequality. Notice that 0 is on one side. Has to have 0 on one side. You can't start until you do. So we're going to proceed just like we would any other problem. We want to find the solutions. Now we call them critical values for these problems, or critical numbers. But we want to find the solutions. So what I'll do is I'll first find the discriminant. So we have b squared minus 4 times a times c. So this is going to be, this is going to come out to be 89. And I say to myself, oh shucks, this is not factorable because 89 is not a perfect square. So I must use the quadratic formula. Alright, so I need to find my two solutions. So x equals the opposite of b plus or minus the square root of my discriminant all over 2a. There we go. I want the two numbers. I want the two decimals. So give me the positive and give me the negative answers. I want them both. So we'll go -5 plus the square root of 89 divided by 4. Let's go to 3 decimal places. I got for the positive 1.108. And let's do -5 minus. And for the negative, I got -3.608. So here are my two solutions to this quadratic. So now what I'm going to do is I'm going to create a number line over here. That's a pretty straight line. Our dots are going to be solid because of the equal to. So I'm going to put a dot at -3.608 and a dot at 1.108. And now I'm going to ask myself, which way does this parabola open? Well, A is greater than 0, which means it opens up. So on my number line here, I'm going to put a parabola opening up. And again, it's just a sketch, okay? It's just a sketch to kind of see where the y's are. Because remember, we treat this guy as y. We want to know when the y's are greater than 0 in this case. Well, they're greater than 0 above. So this is the part of the graph we're going to keep, this above part, including the intercepts, the critical values, because it's equal to. So this is the split answer. So remember, this is negative infinity, this is positive infinity. So we start with negative infinity and we go to our first number, -3.608. And because we are a solid dot, we're equal to it, we use that bracket. Then we're going to unite both parts. Notice we have to skip the middle. We're going to unite both parts. And we're going to pick back up at our next value, 1.108. And we're going to go all the way to positive infinity. And remember, you can't be the infinity, so these are parentheses. These are not brackets. Okay, so let me make sure this is known, that that's a parenthesis around that negative infinity. All right. And there's the interval at which this solution, or this quadratic, is greater than or equal to 0. So hopefully this helped you prepare for your test Tuesday and Wednesday. All right, we'll see you then. Good luck.